Hello everyone, thanks for having me. My name is Teresa Sob and I'm an adjunct associate lecturer at the University of New South Wales in Canberra. Today I'll be talking to you about my research into assessments of cybersecurity implications of new technology integrations into military supply chains. So from here we'll start off by looking at the scope. The background and related work will be the first thing we consider. So this includes looking at the traditional ideas of supply chains and then supply chains within the military context. From there, we'll look at the cybersecurity challenges that currently face supply chains. We'll then look at applications of existing frameworks and processes in those supply chains, followed by the impact of emerging technologies. From there, we will look at a proposed model, the Military Supply Chain Cyber Implications Model, or M-SCCIM for short. From there, we'll look at a summary of the model and also break down the individual model components. From there, we will look at future work in this research and where the project is going forward. This will be the scope of the presentation as we go on. So firstly, what are supply chains? The definition of a supply chain is the network of organizations that are involved through upstream and downstream linkages in the different processes and activities that produce value in the form of products and services delivered to the ultimate consumer. It's important to note that at this point, when we consider supply chains, we're not just talking about logistics, which is the movement of supplies from one area to another, but rather we're considering the complex business processes and interrelationships between different services and elements of supply chains. This includes both within an organization and external to it with the vendors and subcontracting that occurs. Supply chains enable the management of resources and the linking of materials from sources to transformers to users. Supply chains are now cyber-physical systems, and therefore cybersecurity is fundamental in their management. Supply chains are systems of systems. They comprise of multiple systems that are owned and operated by different entities. In that way, they are complex systems and operate over different geographical areas and are subject to weather, disasters, and other timing issues. Trust, therefore, plays a key component in supply chain management and securitization. There are several current trends that influence supply chains. These include globalization, just-in-time stocking, the open marketplace where subcontract is not only normal but encouraged, increased IT and OT overlaps, and the heavy interconnection of supply chains within countries and outside of countries. This is a general understanding of how supply chains operate within the current environment. Next, we'll look at supply chains within a military context. When we consider supply chains, we often consider certain factors that define them. For example, supply chains are often commercially focused, with profit being the primary outcome. They involve the organization of complex business and logical relationships, and they are affected by globalization, world trade, and other different factors. However, when we consider military supply chains, there are a different set of factors that contextualize how these chains operate. Firstly, military supply chains not only have impact to commercial outcomes or profit, but they have potential consequences to human lives and national security. Therefore, their securitization is vital. Military supply chains also have outcomes to tactical and operational force capabilities. Again, this is beyond just profit maximization. The management of military supply chains also involves the interdependence of relationships between government and non-government vendors, and this can pose problems when different vendors have different goals as to what the supply chain needs to achieve and what optimization of that supply chain actually looks like. Finally, wartime operations have the potential to significantly disrupt military supply chains, having effects again not only on just human life and national security, but also compromising those operations. From here, we've considered that supply chains and military supply chains have very different considerations and factors that affect their security, and therefore from a cyber context, we need to consider military supply chains as the niche circumstances of which they are. There are several challenges that currently face military supply chains, although some of these challenges also affect broader understandings of traditional supply chains. Supply chains can be attacked through social engineering, library and protocol exploitation, distributed denial of service, ransomware, partner targeting, poor security controls, and trans-domain threats. Military systems are increasingly connected with commercial platforms, and commercial systems are also increasingly OT integrated, cloud-based, and integrating IoT sensors and systems to enable real-time track and trace. When we consider trans-domain threats to supply chains, we're talking about threats that do not only exist in the cyber or the physical domain, but cross between domains in order to achieve their effects. Such threats include worm attacks on transportation networks, jamming of tracing signals, and compromising of software integrity during production, which can occur at all stages of the supply chain process. Here we can see that there are several challenges that affect military supply chains, and how through these avenues, these chains may be compromised and affected adversely. There are some existing frameworks and processes that can be applied to military supply chains in order to increase their cybersecurity. Frameworks for risk management and system management contribute to how technological impacts to military supply chains can be identified and considered. These frameworks are each focused on individual niches, often in risk or system management, and there is rarely a cohesiveness that combines the two topics together. Existing frameworks can be applied to address some of these issues, but they lack something holistic that addresses symptoms beyond just the small picture. Several techniques may need to be applied together to give a coherent understanding of risk to the system. There are several frameworks here to note. The first being the Cyber Supply Chain Risk Management Model, risk matrices, crown jewel analysis, the Six Sigma die-make model, Lockheed Martin's cyber kill chain, and the Supply Chain Operations Reference Model. Again, I want to stress here that while each of these management frameworks and processes do contribute to understanding of risk management and system management within military supply chains, none of them are able to provide the cohesive and holistic understanding of implications of new technologies to the cybersecurity of military systems, which is the focus of this research. Emerging and new technologies also have a significant impact on how military supply chains operate. Emerging technologies may impact the security of military supply chains in unpredictable ways, and subsequently need to be prepared for these new occurrences. Examples of these technologies include smart contracts and the Internet of Things. Smart contracts are programs that save data to the blockchain. The applications of smart contracts to military supply chains include saving military supply chain data, enabling track and trace, and providing supply chain assurance. Threat avenues for smart contracts include incorrect semantics, transaction ordering dependence, timestamp dependence, and re-entrancy. Through these threat avenues, an adversary may be able to target a military supply chain and therefore degrade its effectiveness. The Internet of Things involves the large-scale integration of IoT devices into modern systems, and this includes the wide-scale use of sensors and smart devices. Applications for the Internet of Things include big data analytics, logistics optimization, and low-level latency track and trace. With these benefits, though, come significantly new threat avenues, from specification limitations to cloud computing implications, big data privacy, and price minimization. Threat actors may be able to find an avenue in which to distort the supply chain process and therefore affect how militaries operate. Through these two technologies examples, we're able to see how, while there are benefits to implementing these technologies into military supply chains, these benefits also come with significantly increased risk, and these need to be understood and mitigated against if possible. Therefore, there is a significant research need based on what we've looked at so far. Military and commercial platforms are increasingly intertwined. Emerging technologies are used in commercial supply chains more and more often, mostly because they do provide a tangible benefit. Military and defense cannot escape this, and in reality, we probably shouldn't want to. There are risks with integrating these new technologies, but more important to those risks is understanding how we can effectively implement them while minimizing the impacts of those risks. The research question then becomes, how can we integrate emerging and new technologies into military and defense supply chains in a robust way? Risk assessment is part of this, but it doesn't constitute all of it. There are more elements that may need to be considered, from maintainability to maturity and supply chain implications that are external to traditional risk analysis. Therefore, significant, ongoing, and not immediately apparent effects exist beyond traditional risk analysis, and that is the crux of the research need in which we are looking at. From here, I'd like to present to you the Military Supply Chain Cyber Implications Model, or M-SCCIM for short. As you can see here, the Military Supply Chain Cyber Implications Model is a three-phase model. It involves the preliminary phase, the pilot phase, and the implementation phase. M-SCCIM is a cyclic model, with each phase going through several considerations before a decision point is reached and a new phase is either conducted or the model's following is terminated. We'll now go into each separate phase of the model to demonstrate how it operates. Phase 1 of the M-SCCIM model involves a focus on understanding the context of the technological implementation. This is the preliminary phase. This phase occurs prior to any physical implementations within the prescribed military supply chain. It provides initial theoretical understandings of the implementation impact of the new technology to the defense context. There is a decision point at the conclusion of the preliminary phase to determine whether the technology is suitable for the next phase, being the pilot phase. There are several considerations that occur during the preliminary phase. The first is looking at source, which includes considering boundary of reach and the level of control that the military supply chain decision makers have over the technology. Next is looking at technological maturity, including exemplar implementations. Technological maturity. This includes community, patches and versions, stability, and the hype cycle. Next, we look at exemplar implementations. This includes the existence of these implementations, the environment in which they've been used, and the different learning opportunities that come from these implementations. Finally, the last part of this stage is looking at the cybersecurity and supply chain implications. These include technologically agnostic considerations and understanding of foundational prerequisites. At the conclusion of phase 1, again, there is a decision point, and based on the information that was gathered, either we continue on to phase 2 or we stop considering the technology for the military supply chain. If we do go on to phase 2, this is the pilot phase. This involves a pilot implementation of the technology into a limited supply chain environment. This means that the technology is not necessarily implemented into the wider defense supply chain context, but into a specific set of circumstances where it can be measured and understood so that we can further understand the cybersecurity risks that may be posed by this technology. So the pilot phase occurs after theoretical considerations in the preliminary phase, but prior to system-wide applications which occur in the implementation phase. The pilot phase serves to provide further insight into the observations made in the preliminary phase, and thus adds richness to the arguments presented. There are several considerations that occur during the pilot phase. First, the pilot is actually implemented into the intended environment, albeit in a limited setting. Next, there is an analysis of the outcomes of that pilot implementation. What worked well, what didn't? What are those observations, and how could they potentially impact the cybersecurity of the supply chain? From there, these observations are considered within the fields of the technologically agnostic and foundational prerequisite considerations that were looked at in the preliminary phase. These are compared and contrasted to see if what was predicted has actually occurred and whether there are any new threats that could potentially impact the cybersecurity of the military supply chain due to the introduction of this technology. At the conclusion of this phase, there is another decision point, and based on all the information gathered within the preliminary phase and the pilot phase, a decision is made as to whether it is suitable to go on to an implementation phase. And if that occurs, the implementation phase is initiated. This phase involves the wide-scale implementation of the technology into the military supply chain environment. The implementation phase is informed by the preliminary and pilot phase observations and their outcomes. The implementation phase also involves the continual management of technology including actual implementation of its methodology outside of the M-SCCIM scope. What this basically means is that at the point of the implementation phase, M-SCCIM doesn't define how that implementation occurs, nor does it have anything to do with the continual security management of that technology. The implementation phase is simply to signify that implementation system-wide throughout the supply chain will occur. So what can we learn from this work, and where is the research going in the future? Well, we know that militaries have a need to understand the cybersecurity implications of introducing new technologies to their supply chains. The modern operating environment makes it imperative that military supply chains are protected from cyber attacks. M-SCCIM is designed to augment existing risk management approaches into a model focused specifically for military supply chain environments. It is not focused on just understanding risk, but understanding consequences beyond traditional risk management and understanding there operationally within a military supply chain context. M-SCCIM is currently undergoing testing and validation within 2 test scenarios. The first of these is a smart alarm system that relies on Internet of Things technology, and the second is a smart contract system on the Ethereum blockchain. I'd also like to provide a disclaimer. The views expressed in this presentation are the authors and are not necessarily those of the Royal Australian Air Force or the Department of Defence. The Commonwealth of Australia will not be legally responsible in contract, tort or otherwise for any statement that is made in this publication. And from there, I will ask for questions. These have actually already been pre-provided to me, so now I will discuss them with you. So the first question is, you described the military supply chain as a complex system. Can you provide an example of complex behaviours? So as we mentioned before, military supply chains interface with a variety of other systems. These can include some contractors, external vendors, suppliers, but they also interface with systems that are not commercially focused. These may include government systems. Physical systems such as weather, trade, and wartime affects how supply chains operate within a military environment. Therefore, while we can argue that military supply chains are essentially complicated when you look at them inside the boundary of the organization, when you consider their external links, they become much more complex, and that's why they are a complex system. The second question asks to explain the role of this work in creating greater resilience in the supply chain. The primary goal of this research is to provide military decision makers with a model that can help them understand the consequences of implementing a new technology into their military supply chains. Without consideration of this, new technologies may bring in further threats or risks to military operations, which can have devastating effects if those risks and threats are exploited by dangerous actors. Therefore, by considering the elements in this model, military decision makers are more likely to understand the impact and consequence of the new technologies that they have to introduce into their supply chains. And often these technologies don't necessarily come at the control of the military vendor. They may include third parties, or they might come from external vendors in which interface with the military supply chain. And this model helps these military decision makers in understanding what that means for their organization and how their operations occur. The final question asks, how does this model deal with deception in the supply chain? For example, a component claims to be made in one location, but may be assembled in another, or may not even be where it was originally claimed to be. So there are several considerations that come with this question. Looking at deception within the supply chain, this can occur at all levels of the supply chain, and the M-SCCIM model particularly focuses on before we actually implement a technology. So if a deception occurs after the initial implementation, the M-SCCIM model is not going to look into that. M-SCCIM stops at the implementation phase. Understanding of source, which was in the preliminary phase, may help with an upfront understanding of how deception may occur within the system. But if it occurs outside of these initial considerations, then the model does not consider that. This needs to be addressed in ongoing security management procedures. In the second part of the question, it talks about components and tracking and deception in the component sources. From that perspective, the military supply chain cyber implication model is instead looking at a holistic understanding of a particular technology. That example is for supply chain assurance, which is a use case of the M-SCCIM model, but is not necessarily the goal of the M-SCCIM model to address. So while that use case should fit into the M-SCCIM model, the actual specific scenario is not necessarily designed to be part of M-SCCIM itself. All right, thank you everyone for attending this presentation. I hope you got something out of it, and I hope you have a good day. Thank you.